you are doing fantastic. I know that we cannot be together in a classroom, but we are going to do our best to keep going through our content. So I know you guys don't have a note sheet for earthquakes, but if you would pause the video and get out a sheet of paper and a pencil, I think it's going to be very helpful for you to write some of this stuff down. So your EQ for this set of notes is going to be, how do plate boundaries create earthquakes? We talked a lot about volcanoes last week. We're going to be moving on to earthquakes today. So as a review, convergent boundaries create lots of pressure. Transform boundaries are going to be where two plates are sliding past each other. And then faults are also going to happen at transform boundaries. So we've already addressed that, but we want to keep that fresh in our brain. So what is an earthquake? Ooh, my bad. An earthquake, if I could get it to click, that'd be cool. There we go. An earthquake is a release of stress as energy. Okay, so whenever plates are moving, it creates a lot of stress, and it's going to be released as an earthquake. So plate movement makes stress. When that stress is released, we have an earthquake. And as you can see from that picture, they can be pretty destructive. We're going to watch this video later in an Edpuzzle because it's not working on my iPad. So where do earthquakes happen? Earthquakes happen along faults, okay? And the focus is the point underneath the surface where that stress begins to be released, okay? So that's the point inside the earth where the earthquake starts. The point on the surface above the focus, we're going to call the epicenter. An epi means above, so if you just think about the point above where the earthquake starts. So the point on the surface above the focus is the epicenter. But all that stress being released starts happening at the focus, which is under the surface along a fault. Here's another picture of that. So the one under the surface is a focus, the one on the surface is the epicenter. Fault types. So there are three types of faults. We've got a normal fault, a reverse fault, and a strike-slip fault. A normal fault is going to happen at a divergent boundary. Okay, so the plates are going to be separating, and we're going to form a rift valley. This picture is really helpful. You can see that one plate slides down the other. Okay, so we've got a tensional force pulling those two plates apart, and this plate that we're going to call the hanging wall block, you can kind of see because it's slanted, it kind of has an overhang. If you look at the middle there, that one's going to slide down the foot wall, and we call it the foot wall because the more slanted part is at the bottom. So that's a normal fault. They're separating, it's a divergent boundary, and one plate is going to slide down the other. So it kind of looks, it looks normal, right? So that looks like it should be sliding down. Whereas a reverse fault is going to happen at a convergent boundary. We're going to have a compressional force pushing those plates together. We're going to form a mountain or a trench there. This is called a reverse fault because it kind of goes against what you would think would happen. You can see the hanging wall is going to slide up the foot block. Okay, so it's going against that gravitational suggestion there. So reverse fault, the hanging wall block is going to slide up the foot wall. And then our last kind of fault is a strike-slip fault. This happens at a transform boundary, and this is where we can see faults. So we saw some pictures of like the San Andreas fault. That would be a strike-slip fault. And this is just shear force working here. That energy is released, and we can measure it. We can use something called magnitude to measure the energy that is released. So energy from earthquakes always travels as waves, and we've got two types of waves that we're going to look at. So we can use P waves and S waves. to kind of measure the magnitude or how much energy was released from an earthquake. A P wave. A P wave is a compressional wave, and we call it a P wave because it's the primary wave. It's the wave that gets there first. It's the fastest moving, and it can move through anything. So it can move through solids, liquids, gases. If you imagine a slinky, a P wave would be like you're pushing it together like an accordion. It's moving in one direction. So if you look at the effects that would have on our environment or land, that back and forth motion can cause the ground to buckle or even fracture. So that's what it might look like if it went underneath a road. Whereas an S wave, I like that it's called an S wave because it moves kind of like a snake and it's slower. So we got all the S's going on. So an S wave is a secondary wave. It's slower than a primary wave. It gets there second, okay, and it moves like a snake. It can also, there's another S word, it can only move through solid surfaces. So you're not going to see this moving through the air. But this one, if you had a slinky or a rope, it's going to move up and down or side to side like a snake, versus a P wave, which is pressing together and apart like an accordion. And this on the land can cause the ground to go up and down or even sideways. Okay. Another type of wave that we're not going to talk too much about, but it's a surface wave, and a surface wave moves in circles. Okay, so this can have some profound effects on buildings and foundations. Anytime you've got movement under the surface, the things on top are going to get shaken up. So what are the effects of earthquakes? Number one is going to be death and property destruction. You guys have seen the effects of earthquakes, luckily not, or hopefully not firsthand, but definitely pictures. Another one is tsunamis. So I'll post an Edpuzzle as well, a short one about a tsunami. That's when an earthquake happens in the ocean, and it creates a big, ginormous wave. We'll see that in a minute. And then also, we're going to form landforms. So we can have faults. If it's a convergent or reverse fault, we're going to have mountains. If it's a divergent or a normal fault, we're going to have rift valleys. And we'll watch this later. Maybe not. I'm struggling, guys. Oh my goodness. No. And sorry guys, I got cut off by the video. I don't know what happened there. But the last slide that we're going to write down is what are we doing about it? We're definitely monitoring using seismographs. So earthquakes produce seismic waves, and we can use a tool called a seismograph to monitor those waves. And we use early warning systems to detect SMP waves and their intervals, so you can tell by how far apart the SMP waves are, how close we are to an earthquake. And then also just educating people about building structure and preparation for earthquakes. That's really all we can do.